Our study demonstrated that mutations in the KIA A1840 gene, also known as a LES5 or a SPG11 gene, cause autosomal recessive axonal Charcot-Marie-Tooth disease.
Charcot-Marie-Tooth disease is an hereditary peripheral neuropathy characterized by a slowly and progressive distal muscle weakness, atrophy, and myosensory loss, especially in the lower limbs. It is the most common degenerative disorder of the peripheral nervous system, with a global prevalence of 1 in 2,500. Up to date, the genetic basis of the Charcot-Marie-Tooth disease is still unexplained.
In 2007, Stevanin et al. Proved that mutation in the KIA A1840 gene, located on chromosome 15, cause autosomal recessive hereditary spastic paraplegia, frequently associated with thin corpus callosum and axonal peripheral neuropathy. In 2010, our research group demonstrated that mutations in the same gene also cause autosomal recessive juvenile amyotrophic lateral sclerosis.
In 3 related patients with axonal Charcot-Marie-Tooth disease, we observed the finding of a thin corpus callosum. This prompted us to investigate the KIA A1840 gene in this family and in other families with axonal Charcot-Marie-Tooth disease.
We investigated 28 unrelated families with autosomal recessive axonal Charcot-Marie-Tooth disease, defined by clinical, electrophysiological and pathological evaluations. This pedigree were collected in more than 15 years of work thanks to international collaborations with several research centers in Italy, Brazil, Canada, United Kingdom and Japan.
Families were screened for all the known genes connecting to the autosomal recessive axonal Charcot-Marie-Tooth disease or other related disorders.
In brief, using linkage analysis and direct sequencing, we identified 15 KIA A1840 mutations in 12 different families. 2 sequence variants were never reported before. No large deletions or duplication were detected in this patient. The novel mutations seem to be pathogenic since they co-segregate with the disease in all the pedigrees and were absent in 300 unrelated controls. Furthermore, in silico analysis predicted their pathogenic effect.
Affected subjects had a mainly distal, slowly progressive, motor and sensory axonal peripheral neuropathy, confirmed by neurophysiological studies. A wide variation of phenotypic expression was detected. The most frequent clinical signs were distal lower limb muscle weakness and skeletal abnormalities such as pes cavus and kyphoscoliosis. Hence, deformities were also present in some patients with a longer disease duration.
Neuropathological analysis of sural nerve biopsies showed intraxonal aggregates of cytoskeletal components representing remnants of neurofilaments and neurotubules. This alteration is typical of diseases affecting axonal transport, such as hereditary spastic paraplegia and amyotrophic lateral sclerosis.
Our study showed novel genotype-phenotype correlation, which further broadens the clinical spectrum associated with the KIA A1840 mutation. Therefore, genetic screening should be considered not only in patients with autosomal recessive hereditary spastic paraplegia with thin corpus callosum, and not only in patients with autosomal recessive juvenile amyotrophic lateral sclerosis, but also in patients with autosomal recessive axonal Charcot-Marie-Tooth disease. In conclusion, the presence of common molecular, pathological and genetic features in KIA A1840 related disease suggests that different phenotypes of axonal degeneration may be targeted by common therapeutic strategies.